Good day, Yusrin, Joshua, Ekeze Enosa. I warmly welcome to Greenville School e-learning, additional mathematics 11 class. The topic for today is permutation, presented by Mr. Matthew, your Add Math teacher. In our previous lesson, we learned about factorial notation. I have some few questions for you to solve in 10 minutes. Start. Thank you. You can cross-check your answers with mine. Okay, let's move on. Today, we want to learn how to solve problems involving permutation. How to solve problems involving permutation. What is permutation? Permutation is an arrangement of a set of objects for which the order of the object is important. For example, given a set of 3 letters, A, B, and C, each possible arrangement, ABC, ACB, would be an example of a permutation. So, looking at it carefully, we have 6 ordered arrangements. How can we compute the number of ordered selections, arrangements, or permutation? We use the permutation formula. The number of permutations of n unlike objects taking r at a time is given by n permutation r equal to n factorial over n minus r factorial, where n equal to the total number of objects, r number of objects taken. Most questions are easily solved using counting methods instead of formula. Let's look at some types of arrangements. Type 1. The number of ways of arranging n unlike objects in a line is given by n factorial. So if you have 10 unlike objects, 10 factorial. 20, 20 factorial. So for the first example, we have A, B, C, D, E. Going by the counting method, you create 5 slots. And these are the 5 slots. The first slot will be occupied by either A, B, C, D, or E. So 5 ways. The second slot, the remaining 4 will take over. The third, in that order. So we have 5 times 4 times 3 times 2 times 1, giving us 5 factorial. Now, going by the formula method, we are selecting 5 from 5. That is 5 permutation 5, which gives us 120. I want you to give this a trial. Now, if you solve it correctly, the counting method, you use 4 slots. That gives us 4 times 3 times 2 times 1. That is 4 factorial. Formula method, you are selecting 4 from 4. That is 4 permutation 4 equal to 12. Give this a trial. Now, for the A part, you have 7 horses to finish. So orderly arranging them gives us 7 factorial, or selecting 7 from 7. For the B part, how many trifactors? 1, first, second, and third. Now, the possible arrangement, going by the formula method, is selecting 3 from 7. That is 7 permutation 3. But for the counting method, the first will be occupied by 7, followed by 6 and 5, which gives us 210. Type 2. The number of ways of arranging n objects in a line, of which p of one type are alike, q of one type are alike, and r of one type are alike, equal to n factorial over p factorial, r factorial, q factorial. An example is this. If you have minimum to arrange, how many letters are there? 7. M appears 3, I appears twice. So that gives us 7 factorial over 3 factorial 2 factorial, which is 420. Another 12 question for you. If you solve it correctly, the answer will be 50,400. Let's write on. For type 3, it's all about circular. The first goes like this. The number of ways of arranging n unlike objects in a circle when clockwise and anti-clockwise are different is given by n minus 1 factorial. Here, realize that if you want to arrange n objects, you need to pin one down, remaining n minus 1. So it's the n minus 1 which will be orderly arranged among themselves. That is giving us n minus 1 factorial. An example is when people sit around a table or arranging things around a circular shape or object. For the second type, we have the number of ways of arranging n unlike objects in a circle when clockwise and anti-clockwise are the same. This is given by n minus 1 factorial over 2. Examples are found in beads and bracelets. Let's take an example of this type. 3 red, 4 blue, 1 white, 5 green beads are threaded on a ring to make a bracelet. How many bracelets can be formed? Solution. If the 13 beads were to be considered having the same colors, we have 13 minus 1 factorial over 2. Considering the different colors, we need to take into consideration the 3, the 4, the 1, and the 5. So that gives us what? 13 minus 1 factorial over 2. Then the 3 comes factorial, then the 4 factorial. 1 factorial is 1, so we ignore it. Then 5 factorial, giving us 13,860. This is another type. I know it's very easy. Arranging 5 around the table, that is 5 minus 1 factorial. Now, aside the 3 types, you can have miscellaneous questions which involve restrictions. So I want you to give this a trial. For A, no restriction. No restriction means arranging 5 and 4 among themselves. 5 and 4 equal to 9. So combining them without any restriction gives you 9. That is 9 factorial, or selecting 9 from 9. Let's look at the B part. Boys and girls alternate. In this case, we start with a boy followed by a girl in that order. So that gives us 14,400. Thank you. I have an assignment for you. Make sure you do it and you submit your response to my Gmail, to my email account as shown below. Thank you. Thank you and stay safe. Bye for now.